Okay, in this video today we are going to talk about symmetry. Symmetry being two different things. We're going to talk about lines of symmetry and we're going to talk about angles of rotation. So what we want is we want the same picture. One way or another we want the same picture. So how we do that is we start to look at these and can we fold it in half somewhere? If I go right down here, can I fold this side and have it match the other side? Will it flip over onto that same side? And the answer is yes. So this is a line of symmetry. Okay. Now let's look at, well, if we can do it left to right, can we do it top to bottom? Sure can. And you can see if we highlight it again, this side is going to be identical to, well, let's try this. Maybe if I show another color, we can see that these two sides are going to be identical to each other. So you can see the pink and the yellow are equal sizes. Okay, so sometimes I think those are the easy ones, and this is the more tricky one to see, because if we highlight this, it looks more of a crown, but if we highlight this side, hopefully you will see that it's the same size crown as the other side. So you can clearly see those two halves are equal to each other. So if you can bend it that way, hopefully you see you can bend it this way as well. So how many lines do we have? Well, start it here, and we're going to call this 1, and then 2, and then 3, then 4. But when we get down to here, that's the same as 1. So there are 4 lines of symmetry in this figure. Now, if we are looking for angles of rotation, if we spin it all the way around, one circle ends up being 360 degrees. That's a full circle. When we get from the beginning back to the, or get to the end and it's right at the beginning, that's 360 degrees. So if we take that number and we divide it by the number of lines of symmetry, we will see that this actually has angle of rotation symmetry into 90 degrees. So every 90 degree turn we do, we are going to hit the same spot. But it only is going to work at 90 degrees and 90 degrees and 90 degrees and 90 degrees. Otherwise, it will not work. Okay? So let's look at figure number 2. If we give this a shot, and I'm not saying it is, but we could try it. Look what happens. Shoop, shoop. Just like that. And if we change the color, is this the same size on the other side? And man, that sure looks like it. So that would be my first one. Now let's try through it this way. And that would be number 2. And yeah, you're starting to see it. Here is number 3. Cutting it through here. So we have 3 lines, and take 360 and divide it by 3. Every 120 degrees, so that would be 120 degrees, we would get it. Then this would be 120 degrees. And then we would get back after 120 degrees to the original picture. So this has rotational symmetry about 120 degrees. So that's how we do rotational symmetry. Okay, so let's try another one. The next 2 in your notes are going to look like this, where hopefully this one would definitely be one where you're going to want to measure or do something, but they are definitely, when we're talking about this, they're not trying to get nitpicky. They're literally saying that the top is going to be equal to the bottom. So this one does have, you can fold it in half that way. And I don't know if you can see this one or not, but the hourglass, the hourglass is going to be equal to the other side of the hourglass. And hopefully you can kind of see that those two are equal as well. Okay. I don't really see anything else like trying to fold somewhere. I don't think that's going to work. So this one really only has two lines of symmetry. And if we take that 360 and we divide it by 2, now we can only have rotational symmetry when we spin it 180 degrees and then 180 degrees. So it still has rotational symmetry. It's only 180 degrees because when you take 360 divided by 2, that's how we get it. So you really only get one spin, and we can flip it over, but then when we spin it again, we're back to the beginning. So next picture, if I fold this right in half, I have this space up here, and I have this space down here. But hopefully you're sort of saying to yourself, well, this one sticks out higher than that one. Yeah, that is not a line of symmetry. Okay, so what else could we do? Well, we could try and fold it in half, but hopefully you can already start to see there's a rectangle here and a trapezoid there, so that doesn't work. Can we take a diagonal approach? I don't think this triangle down here looks the same as that triangle. So this is the case where you will not have zero, or you will have 0 lines of symmetry, and it's not necessarily rotational symmetry, but if we were to spin it all the way around, we would get back here. So if it's 360 degrees, it does not have rotational symmetry. It's just we're spinning it back into place where we started from. So there's no rotational symmetry either. So we would put none here. All right. That's that case where you might not have any. Okay, final two. Let's look at this. So a star, we can fold down each of the pieces of a star. And then we can fold through each of those points of the star to get half and half. And we can go this way. And then we could go this way. So once we do that, we're going to have 5 lines of symmetry, and divided by 5, well, that would be 5 goes into 35, what, 7 times? 72 degrees? Wow, that's kind of weird. But if we rotate it every 72 degrees, this point would fall on here, would fall on there, would fall on there, would fall on there, would fall on there. And we would get that same picture falling on top of itself as we rotate it around. Okay. And final one, we can split it this way. We can split it that way. We could split it that way. So each one of those works. But can we fold it this way? And you might be asking yourself, well, I don't know. Well, let's look at the highlights then. We've got that side. And then we've got this side. That looks pretty familiar, right? Those kind of look equal to each other. So if that's the case, then we can fold through the middle of each of these as well. So we could fold through the middle here, and we could fold through the middle there. So this one, we have 1, 2, 3, 4, 5, 6. And then once we get to here, that's still the first one. So there are 6 lines of symmetry here. And 36, so that would be 60 degrees. So every 60 degrees, we would fall back onto the same shape again. So unless we ordered each part of the vertex or vertices, we wouldn't even know that the shape was different each 60-degree rotation. We would flip it and you would see the same picture. And that's lines of symmetry and angle rotation. Please hit a like and follow or do all those good things. Much appreciated for that. And I'm going to stop this video.